All right, in our first video, we're going to look at some visual representations of radical expressions. So how can you visually show that the square root of 16 is equivalent to 2 times the square root of 4? So here is a square, and we can see it has 1, 2, 3, 4, 4, 4, 4. It has 16 total units. Because it's a square, to find out what one side of it is, right here, we would take the square root of that total area of 16. So this side length can be represented by the square root of 16. So over here we have a big square with an area of 4 units, and to find one side length, we would take the square root of the total area 4, and the reason why we're taking the square root is because it's a square. All right, and then we have another one over here. Area is 4, so that square root is equal to 4, or that side length is equal to the square root of 4, excuse me. So notice how this is this many units long, which is broken down into 2 of those. So essentially what we're showing visually is that the square root of 16 is equal to 2 of those square roots of 4. So square root of 16 is equal to a square root of 4 plus another square root of 4. And then how many square roots of 4 are we adding together? There are 2 of them. So 2 square roots of 4. So we just showed a visual representation that square root of 16 is equivalent to 2 times the square root of 4. All right, well, we're going to move away from our visual representations, and then let's do a similar comparison with some square roots. So how can you compare the square root of 20 and 2 times the square root of 5? Well, we're going to take the square root of 20 and rewrite it as the product of square roots. So we're going to use that property that we talked about in our intro video. So square root of 20, we can rewrite this several ways. We can rewrite that as the product of 1 and 20, that's one factor pair. So square root of 1 times square root of 20. Square root of 20 can also be written as the square root of 2 times 10. So square root of 2 times square root of 10. We also could write the square root of 20 as the square root of 4 times 5. And then that breaks down into the square root of 4 times the square root of 5. All right, so hopefully we can see that you can take any number and break it down with its factor pairs and rewrite it with new square roots. So why would we want to do that? Well, if we can find one of the square roots that we could simplify a little bit further, if we can find a perfect square factor, then we're going to get somewhere with this. So this one over here is the one that has the perfect square factor. We know what the square root of 4 is. The square root of 4 is 2. So the square root of 20 is equal to 2 times the square root of 5. Those are equivalent statements. And that's how it compares.